Hello, in this video I will try to see how Reuteri grows in milk. I see people discuss this a lot, so I decided to try myself. People often asking like how long the fermentation time should be or how many bacteria you can get from milk. Well, to understand this, we have to understand how the bacteria, the Reuteri, grows in milk over time. So the best experiments for this is to do a growth curve. A growth curve can describe how bacteria number change over time in particular medium. So in this case, I will use fresh milk to culture Reuteri and do CFU count at different time points to see how the bacteria grow. First is to acquire the bacteria. The bacteria I bought is this one, since I cannot find the product that most of the video on YouTube uses. They either don't sell here or I cannot find them. This product only have Reuteri listed on the description, but after I strict the play for pure culture, I find out there are another bacteria involved. Here you can see I got two different colonies, one is gray and one is white. I believe this is due to the regulation that allow products to not list the bacteria it has if it's lower than certain percentage in the product. But it still took me to do a DNA sequencing to find out which one is the Reuteri I want. At first, I thought this going to be a long process, but luckily it turned out well, and now I know the gray colony is the Reuteri I want, and the white one is another lactobacillus. It's called L. fermentin. Now I have these two bottles of fresh milk from the same batch from the market, and one of it I'm going to inoculate with some Reuteri that I cultured as starter and do a CFU count right away to mark the 0-hour time point. The other bottle will act as control group with CFU count as well. Both bottles will be incubated under 37 degrees Celsius or 98 to 99 degrees Fahrenheit without light and shake. The time point I select for this experiment are 2, 4, 6, 8, 12, 24, 48, and 72 hours post-inoculation. For each time point, I will first mix the bottle by inverting it 60 times and take 1 milliliter of sample from each bottle to do the serial dilution and plating. The plates will incubate 48 hours under the same condition as the milk and do the CFU count. Well, after a whole lot of work, the results are here. We can see the bacteria grow from an initial number of 1.13 times 10 to the power of 4 CFU per milliliter all the way to 5.33 times 10 to the power of 6 CFU per milliliter during these 72 hours, which is, well, I would say not a lot. The growth curve look like this. We can see better using the log display here. From here tell us bacteria numbers start increasing during this 4 to 6 hours time, entering a log phase growth, and start to slow down after 24 hours. The curve suggests that bacteria number will max somewhere around 6 million CFU per milliliter. Also, if we look at growth rate here, indicate the bacteria start to grow after 4 hours post-inoculation and achieve maximum growth rate between this 12 to 24 hours, which is 1.8 times 10 to the power of 6 CFU increase per hour. After that, the growth rate drops significantly. Also from this graph, we can estimate the bacteria will mostly stop growing at the 96 hours. Also, no separation of the milk was noticed after 72 hours. However, the control bottles start to bubble after 12 hours and separated at the end, suggesting that there are other bacteria growing inside it. Well, fresh milk are not germ-free, so that's to be expected. Luckily, this bacteria cannot grow on the MIS medium I use, so it will not interfere with the CFU count. The result gave me some important information and interesting material for thought. That Reuteri might not grow very well in fresh milk to a very high number compared to commercial product you can normally find, which mostly have bacteria count up to the 10 times the power of 9. That is, in this case, 1,000 times more. But since you can eat much more in volume compared to a capsule or tab, there might not be that much of a difference. Professional yogurt making requires some process to pre-treat the milk to make it more suitable for micro-growth. This might be the reason for the low bacteria count in this experiment. I'm using fresh milk I got from the market without any modification, since that's what a lot of people use as well. But it will be interesting to see how this will change if I add in some pre-treated process to the milk. And what about the result of separation seen in other videos, or the effect of adding something like inulin or using condensed product like half and half? Different medium or inoculation culture might change how bacteria behave. Also, the product from the market are dormant bacteria and might probably act differently. Those could be the point to investigate in the future. These experiments bring me a lot of questions, and I'm sure you too. What would be your question? You can leave down below in the comment. It is very interesting to see what's really going on. See you next time. Bye bye.